Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 1 Higher Tier from 2020. Question number 3 is on the topic of electricity. A student investigated how resistance of a piece of wire varies with its length. This is actually a required practical that you need to know about. Figure 2 shows the circuit used. So you have a battery, an ammeter. This is a variable resistor. The wire and the voltmeter. And this is a series circuit. The voltmeter is connected parallelly across the wire that is being tested. So the circuit is actually connected correctly. Explain why the student needed to adjust the variable resistor each time she changed the length of the wire. Now, when you change the length of the wire, you are going to change the potential difference across the wire. And that also changes the current in the wire because the resistance will change. Now, if you want to keep the temperature constant, because if the temperature of the wire gets hot, it will get hot if there's too much current going through. So you want to actually keep the current the same. So in order to keep the current same, you need to adjust the variable resistor so that some of the potential difference is actually taken up by this, and you're maintaining the same potential difference across the wire. So the variable resistor changes the resistance of the circuit to keep the current the same, so the temperature of the wire is kept constant. The student recorded 3 measurements of the potential difference across a 0.1 meter length of wire. So at 10 centimeters, you got X, which is the missing value, and you have been given the mean. So 0.17 is actually equal to X plus 0.18 plus 0.15 divided by 3. So rearranging the equation, 0.17 times 3 is equal to X plus 0.18 plus 0.15. Now, if I find the values for this, 0.17 times 3 is 0.15. Oops. There you go. 0.51 is equal to X plus, let's add up, 0.18 plus 0.15. That gives me 0.33. So X equals 0.51 minus 0.33. That's equal to 0.18. 0.18. Figure 3 shows the results of 5 different lengths of wire. So this is a line graph with the length of wire in meters in the x-axis, because that's the independent variable. The dependent variable, which is on the y-axis, is the resistance, and it's a straight line going through 0. So that's actually directly proportional because it's a straight line going diagonally. Describe the relationship between the length of the wire and the resistance of the wire. The answer is resistance is directly proportional to the length of the wire. Most students would often say that as the length of the wire increases, the resistance increases. That just gives you 1 mark. You need to use the word directly proportional to gain the 2 marks. A glucometer uses the resistance of a blood sample to calculate the glucose concentration in a person's blood. A blood sample is put into a small tube which is put inside the glucometer. The blood then acts like a resistance wire. Figure 4 shows the relationship between the resistance of a blood sample and the glucose concentration. So this again a line graph where the lines going down. On the y-axis is the resistance of the blood. It's starting at around 13 ohms, slightly above 13 ohms, and it goes down to about 4.4 ohms. And the glucose concentration in grams per liter is on the y-axis. So as the glucose concentration increases, the resistance is actually going down. The glucometer applies a potential difference of 0.9 volts across the blood sample. The glucose concentration of the blood sample is 0.9 grams per liter. Determine the current in the blood sample. So if the glucometer applies a potential difference of 0.9 volts and the concentration is 0.98, we need to find I. So we've got the voltage, we are trying to find the current, we need to know the resistance as well, so we can use V equals IR equation, Ohm's law equation. To find the resistance, we are going to use the blood glucose concentration, which is 0.98 grams. So 0.98, 0.9, and that's 10 boxes. So 0.98 is here, which is 2 boxes away from 10. So it's right over there. And this is 7. So halfway is 7.5 ohms. So resistance equals 7.5 ohms. 0.9 equals I times 7.5. Rearranging the equation, I equals 0.9 divided by 7.5. That gives you a current of 0.12 amps. 0.12. A new tube is used each time a blood sample is tested. Explain why valid results are only obtained if each tube is identical. Now, if the tube is not identical, then the length or the width or the volume of the blood inside the tube can be different. All of this will actually affect the resistance of the blood. So the glucose concentration can actually change. So the length, width, and volume of the blood sample affects the resistance of the blood sample. So only glucose concentration affects the resistance. So you want to keep all of them the same every single time. That brings us to the end of question number 3, and I will see you in question number